So I promised another video just to show you guys how to use Excel to calculate standard deviation and save you a little time. So what I'm going to do in this video is kind of show you how you can break down, determine the standard deviation one step at a time, and then how can you represent that standard deviation in your graphs so you get some understanding of where error shows up graphically. So this data is one of the students who already submitted their work for the golf ball lab, and I'm going to show you how you can take this data and calculate standard deviation. Okay, so the first thing we want to do is we'll do it one at a time. So I'll do the white one and then I'll do the yellow one. So right now they're close together, but we want to find standard deviation, so this is sort of like a step-by-step process. The first thing we want to do is open up some space. So if you've got a bunch of columns stacked one after another and you want to have like a spot in between, if you click on the column, it'll highlight the whole column. Then you can right click there and there's insert. So when you do that, Excel puts in a new column, empty column, right where that spot was, and allows you some room to work. Okay, so in this one I already set up the two averages or our means for the data sets, but we're going to use that in order to find the deviation, right? So our deviation, not the standard deviation, just the deviation is the difference between the value, like a particular value that we measured, and the average value, right? Because basically the standard deviation is going to be the average of all that, all those deviations, right? So how we're going to do this, we're going to first, well, let me show you what happens if you don't put a name in, right? So right now this column is, average, and it says it's B13. That's the name for it. So if I go to try to do the deviation and say that it's going to be equal to taking the value minus the average, right? I hit enter. That's the difference between this value and the average. You can even see it, right? Difference between that value and the average. So then I can try the trick of just dragging it down, and what I get is something that doesn't quite make any sense, right? You see how all these ones are, it didn't change them, so that's not what we want. And the reason for that is if you look at what they're dealing with is when you don't name the value that you want to use, Excel is going to move down, because that's how it kind of works. It moves it down every box each time you go down. So if I look at this box and I look at the function, you see each time you go down, it's going down another Excel thing down the list. So we don't want that. We don't want it to look at blank spots, because that's not helping us. So what we're going to do is we're going to name this average. I'm going to call this one white average, because that's the white av, because that's the average fall time for the white golf ball in this case. Right? And I'm going to rename my function as B2 not minus B3, but now when I click on the box, it's that variable. It's named white av. Right? And so when I do that for all these values, there it is. Right? So that's all our average deviations, all our deviations, right? And if I take the average of that and I'm going to clear a new box, right? Now, when I go to try to, one thing you could do is horizontally, you can shift a function over. So this one takes the average of all these numbers. If I slide it over to the right, it'll take the average of all the numbers above it. In that case, it's 0, which is the problem. Remember, we can't just take the average deviations to get standard deviation, because all these positives and the negatives, they cancel each other out when you try to average them. Right? So we can't do that. So what we do is we square our deviation. Right? So to square it, we're going to take that value and we're going to square it. That makes, pretty straightforward. Right? So now we've taken the deviation value, we've squared it, and what that does is it gets rid of all these nasty negative signs that we want here, right? And so the average of all of these squares of our deviations, right, we call that a special name. It's called the variance, right? The variance is literally just the average of all squares of the deviation. Right, so I'm going to slide that average one over one last time. And there you go. That's our average variance. Going to put another column here, clear up some space. Right, so lastly, to get standard deviation, we're going to square root our variance, because that's how it's defined. Literally, is the square root of the variance. So we put in the equal sign. We type in the word SQRT for square root, right? Then we click on the one that's the variance, and then enter, right? And right there, that's our standard deviation. And let's just clear that down to 2 digits, right? And the standard deviation should be in seconds in this case, because we're dealing with golf ball times in seconds, right? And there you have it. We did the whole thing for the white golf ball, right? Let's make this so it's all together. Great. So let's do it again for the yellow. Same idea. Pretty straightforward. Name this one. I'm going to name this one the yellow average. Alright, so now it's got a special name. And then that's going to be equal to taking the value minus the average, right? Because that's our difference between the point value and the average. And then we're going to do that for each value, right? Call that our deviation. Right. Then we can then square that, right? And so the square root, which is our squares of our deviations, just hit the equal sign, click on the value we want to square, then raise it to the second power, highlight bringing it down, and all those nasty negatives go away, and we're in good shape, right? And we slide our average all the way over, and that gives us our variance, right? Our variance is the average of the squares of the differences between the point values and the average. I know it's a little complicated, but when you get the handle on it, it's pretty straightforward to do. Finally, to close it up, I'm just save myself time. I'm just going to copy and paste, right? Our standard deviation is going to be equal to the square root of the variance, right? And then we're going to bring it down this way, close down only 2 digits since our stopwatch only has 2 digits, and basically they're exactly the same in this case because this data is great. I mean, they're both, it's very well taken and it's kind of all evenly distributed in the right way. Okay, so that's wonderful. So that means that we know that for the white ball, the white fall time was 0.75, right? And then the plus or minus is going to be we not have this stuff in there. Okay, well then the error, we'll just write it as a word so it's a little clearer. So our error is, well, we said we're going to do 2 standard deviations, so we have 95% confidence that the truth is somewhere around there. So 2 times 0.1, our error is going to be plus or minus 0.2 seconds. Right? And then the yellow fall time. The yellow fall time was, for this case, 0.76 seconds, 0.77 seconds, 0.77, right? And the error is again the same thing, 0.2, right? And this makes it very, very, very clear. So that means that the largest value it could be, according to our experiment, is going to be equal to that value plus our error, right? That's the largest number it can be. And the smallest is going to be equal to that value minus our error, right? Because remember, the error basically gives you sort of a bracket between your largest value, wherever it is on the top, and your smallest value, where that would be on the bottom. And we'll do the same thing for the yellow fall time. I'm just going to copy and paste, save a little time, right? And I can even, let's see, might be able to just copy and paste the formula. Yep, it worked out just right. So for this case, the largest was the 0.77 plus 0.2, right? And the smallest was the 0.77 minus the 0.2. And so right there. Now, this is how we know for sure that you can't tell the difference between the white golf ball and the yellow golf ball, because you look at the value sets, they totally overlap with each other, right? And then when you look at the average, you know, they'll be in the same zone. Now, how can we represent that on the graph? Well, when you've got something like this where you have error, you can represent it using error bars, right? Because these numbers that are on this graph, they're not truth, you know, like they're sort of like our best, they're close, very close guesses using a stopwatch. You know, you're using a stopwatch, and when you click the stop or the start time, you're getting like a close to the truth, but not exactly the truth. So we take this error that we found, and we want to represent it on the graph to show that each of these data points could be something bigger, could be something smaller, based on looking at, you know, how the data was as a whole, right? So to do that, we could go into the chart, and then there should be something we can format. Let's see if we can find it. Right? Let's look on the chart. Format chart error. Nope. Add chart element. That's what we want, right? Because if you go down to add chart element, we'll find error bars, right? So they do some options, but these don't really make any sense because there's no error on our let's fix the labels here. These was our trial number, right? And this was our fall time in seconds, right? So when we go to you know, add new chart, go to the error bars, the standard error doesn't really make any sense, because you see that there's like a horizontal, there's horizontal bars, like the left and right bars. That doesn't make any sense, because our trial numbers, you know, it's not like we were guessing that was trial 2. We took trial 2. So when you got this kind of stuff in here, this is silly. So what you want to go down is the more error bar options, right? So we're going to add error bars onto the white, right? And then over here, format, we can fix this thing a little bit. So we want to here it is, right? So you got it's down by the error bar options on the thing. So we want the vertical error bars, check. And we want the fixed value. The fixed value is going to be our error, which in this case was 0.2, right? So that's clear. Now, I don't know why they're not, oh, I think we got to click on the horizontal bars to fix that. So the horizontal bar errors, we don't want any horizontal bar errors. So we're gonna see if we can get rid of them somehow or another. So 0. There you go. Problem solved, right? And just like that, we've got that thing taken care of, right? So we did that for the white golf ball, right? Now let's do it again for the other one. Error bars, more error bar options. Let's go with the yellow bar this time, right? So the yellow one, we want to have both, but the fixed value is going to be 0.2 again, because that's the way it goes. And then we click on the horizontal bars, and we don't want them, so we're just going to make that 0, right? Check. And I believe that should give it to us, right? And this clearly now shows that each value, they overlap each other in terms of our error, right? So like if you look at these two first points, you know, truth could have been all the way down here for the blue guy, but it also could have been up there. So this whole zone from that line to that line could be the truth. So this means that there's no way we can distinguish between the yellow golf ball and the white golf ball, and it sort of illustrates the point of the lab that it's not the weight that does this, it's about you know, basically air resistance. And in this case, when they're the same size with the same area, you should have the same thing. So I hope that was helpful, and now you know how to find standard deviation. Pretty easy. And you can use error bars, right? It'll be a little different depending on the Excel version you use, but that's it. All right, good luck.